Hello, and welcome to Teaching with Tech. Recently, I've discovered just how powerful AI can be in creating online simulations to support science education. For context, the last time I did any programming was back in the day on an Acorn Electron. But with today's AI tools, even I can now generate working HTML code for real-world classroom use. As many podcasts like to say, the new coding language really is English. The real key to success here is iteration. For my current project, I've gone through at least 30 versions of the same simulation, each one just a bit better than the last. Now, good writers show rather than tell, so today I want to show you how I use AI in my workflow. I'll walk you through the process I used to develop an interactive simulation for the CIE IGCSE topic, Rates of Reaction. I worked with the base subscriptions to two AI models, Grok 3's Thinking Mode and ChatGPT's O1 Reasoning Model. Because of daily query limits on the more advanced models, I often switch between the two as needed. To kick things off, I gave Grok 3 a detailed prompt describing the reaction's setup, how I wanted reactants and products to be visualized, and what variables should be adjustable, like concentration or surface area, using sliders with specific ranges. My general workflow is straightforward. Ask the AI to generate HTML code. Copy the code into a text editor. Save it as HTML file. On a PC, choose all files as the format. On a Mac, convert it to plain text and then save with an HTML extension. Double-click to open the file in your browser, and voila! I won't go through every version, but I'll highlight most of the key moments from the design process. The first version worked, but barely. The simulation ran in real time over 5 minutes, way too slow, and there was no graph to visualize reaction rates. The next versions sped things up, added a graph and introduced a start button, but frustratingly, it removed the solid particles and sliders I'd asked for. A few versions later, the sliders and solids returned, but the chemistry wasn't quite right. Particles reacted sequentially rather than randomly, and acid particles passed through solids without interacting. Grok tried to fix it, but the results weren't realistic. When I hit Grok's advanced model limit, I switched to ChatGPT O1. After a few conversations, I saw major improvements in collision physics. But now, acid particles were spawning inside the carbonate structure, dissolving it from within. We tweaked particle sizes and refined the collision rules, but then the reaction became too slow. We fixed the rate, but now reactions were sequential again. Another tweak fixed that, but created a mismatch between the animation and the graph. Eventually, ChatGPT helped me spot the issue: collision efficacy. By experimenting with this value, changing it from 0.6 to 1.4, I finally achieved a realistic match between the visual reaction and the data graph. Next, I added a repeat trials button so students could run experiments multiple times, with each trial recorded in a new column. At first, the data was offset by one row, but we fixed that. Then, we linked the results directly to the collisions in the animation, introducing realistic variability in the data, a great improvement for students thinking critically about experimental design. Another issue cropped up. All trials started collecting data at 10 seconds rather than immediately. I couldn't solve it by editing the equations, so I asked ChatGPT to insert a placeholder 0 point at the start and ignore it in the rate calculations. I also extended the y-axis limit, so all data points remained visible and clear. I wanted students to be able to change conditions between trials and have these settings clearly labeled in the table headers, so there's no confusion when comparing results. From there, I made several small improvements. Tweaked the precision of the data to match realistic gas syringe measurements. Added a key to the graph. Refined the interface so it was intuitive, even tested it successfully with my wife. Finally, it was time to put the simulation online. My first attempt was to upload the code to GitHub and embed it in a Google site, but that caused sizing issues. When I hit my ChatGPT 01 quota, I switched to ChatGPT 4.0, which pointed me toward Netlify. Hosting the file there fixed the display issues, and now the simulation works exactly as intended. This has been a long process, but also a hugely rewarding one. I hope that by sharing my journey, I've helped you feel more confident in using AI to create custom teaching resources, especially when the available materials don't quite fit your classroom needs. Thanks for watching. See you next time on Teaching with Tech.